Hello and welcome back. So we're going to look at calculations now with that second order integrated rate law. So we've got a reaction A goes to products, and we've got a rate law, rate is equal to K times A squared. So that's telling you it's second order because you got a 2 up in this position here. And we saw in the last lecture, right, that rate law has an integrated rate equation, an equation that allows us to calculate concentration versus time that looks something like so. So we can do our calculations. For example, we might say, well, what's the concentration of A after 3 minutes? Okay, if the original concentration of A is, say, 0.1 moles per liter, and the rate constant is 0.3 molar to the -1 seconds to the -1. So we can go ahead and we can calculate that using the second order rate law. And what are we doing here? We're essentially solving for this. So we can go ahead and we can just invert the right hand side, and then we get this. So we know that the concentration at some time t is 1 over this whole thing, right? So 1 over kt plus 1 over a sub 0. And I believe we can just kind of plug and chug away. So we've got our rate constant is 0.3 molars to the -1, seconds to the -1. We multiply by the time. And it's in minutes, right? So minutes and seconds aren't going to cancel, but we know there's 60 seconds in a minute. So 60 times 3 is 180 seconds. So 180 seconds. All right, what do we have? Plus 1 over the original concentration. So 1 over 0.1. Molarity. Okay, so let me see if I do this on my calculator, and you should probably double check as well. In fact, maybe you can pause the video and see if you get the same thing I do. Okay, so did you get 0.016? And what about the units? So we can go ahead and we can see the units here. Seconds to the -1 and seconds cancel. So that's reciprocal molar. And that's reciprocal molar. So when you add these together, you get reciprocal molar, and you are reciprocating it. So you're back to molar. So at the end of the day, it has units of moles per liter. Does that make sense? I don't know. Does it make sense? I mean, it's kind of hard to tell, but you start with 0.1 and you end up with 0.016. So at least it's gone down, right? So we would expect the concentration versus time curve to go down. And so, yeah, that kind of makes sense, right? I mean, if it was bigger than 0.1, a reactant's not likely to increase in concentration. So that at least passes the bozo check, huh?